All right, so today's lesson 1.6, solving inequalities and graphing on a number line. So go ahead and you only have one warm-up problem for today. The answer is x equals 6, so make sure that you get the right answer, and if you didn't, go back and check and see where you made your mistake. All right, so your inequality symbols are, if you have trouble remembering these, you can always remember the number line. Okay, so let's take a quick look at a number line right here, where 0 is here, and then I have my positive numbers going this way and my negative numbers going this way. So if you look at your basic number line, the greater than symbol is on the bigger number side. So this is going to be greater than. And then the less than symbol is going to be on the negative number side, which is over here. This is going to be less than. So the only difference between these two here and these two here is this line right here, which is a short version of an equal sign. So this says less than or equal to. Okay, so I could have less than or equal to, and then this, of course, would be greater than or equal to. Okay, so the only difference is the line underneath. Graphing inequalities on a number line, so we're going to get into this in just a minute. So if I have a less than symbol, I'm going to have an open dot. So it's going to be an open circle like this. And I'm going to have my arrow shading to the left, which is the same direction the arrow points. Okay? If I have a less than or equal to symbol, I'm going to have a closed dot. Means I'm going to fill in my circle, and it's going to still have the arrow to the left, same as the arrow point. So the only difference is the closed or the open dot. Because they're both less than, they're both going to be shaded to the left. The greater than symbol is going to have an open dot, so it's also going to have an open circle, except this time my arrow's pointing this way, so it's going to arrow to the right. Okay, this is greater than or equal to, so it'll have a closed dot. So it'll look like that, and again, arrow to the right, same direction as your symbol is pointing. It's pointing this way, so that's the way that you're going to shade. So you're probably wondering what all this means, so let's together. X is greater than -3. So I'm going to find a spot on my number line and call it 0. Right here. I'll just call that 0 right there. Right, so then I'm going to go to -3, which is -1, -1, -2, -3. So right here I'm going to put a circle, and then I'm going to look at my symbol and say, is that supposed to be an open or closed dot? Well, because it has no line underneath, it's going to be an open dot, and I'm going to shade the same direction as the arrow, so I'm going to shade this way. You're probably wondering what that means. Well, when I have inequalities, I don't have just one answer. Like typically up until this point we had x equals 3, where I only had one answer. Well, in this instance, I have x is greater than -3. So any number greater than -3 or bigger than -3 is going to make that a true statement. For example, I could plug in 0. 0 is greater than -3. That's true. I could plug in 1, 2, 3, 4, 5. I could plug in 5, which is also greater than -3. I could even keep going and say 1,000. 1,000 is greater than -3. So when I have an inequality, I don't just have one answer. I have an infinite number of answers, a million bazillion numbers that are bigger than -3. All right, let's look at the next example. X is less than 5. All right, so I'm going to find a spot on my number line, and I'm going to call it 0. And let's find where 5 is. 1, 2, 3, 4, 5. And because this is a less than symbol with no line underneath it, I'm going to have an open circle. But this time my arrow is pointing to this direction, so that's the way I'm going to shade. Okay, so let's talk about what that means. That means that x has to be less than 5. So whatever x is, whatever number I plug in for x has to be smaller than 5. So any number I plug in down here is going to be smaller than 5. For example, I could plug in 0 is less than 5. I could plug in negative 100 is less than 5. Any number that is over here will work. We'll make that a true statement. X is greater than or equal to 0. Okay, so let's find a place and call it 0, and I'm going to put a circle there. The big question is it open or closed? Since there is an underline under here, that means I have to fill in my circle. And then I'm still going to shade the direction of the arrow. It's pointing that direction, so I'm shading in that direction. So any number over here to the right of 0, if I plug it in for x, is going to make that a true statement. So let's try one. 5 is greater than 0. That's true because 5 is over here someplace. 1, 2, 3, 4, 5. If I plug 5 in for that or inequality, it makes this statement true. All right, x is less than or equal to 4. So I'm going to find a spot and call it 0. So that's 0 and 1, 2, 3, 4. I'm going to put a circle at 4 because that's my starting point. Because of the equal sign, I have to fill it in. And because this is pointing to the negative numbers, I have to shade to the negative numbers. And that is my solution. Any number less than or equal to 4. Let's talk about that equal sign for just a second. This says less than or equal to 4. So if I plug 4 in there, while 4 is not less than 4, it is equal to 4, and that is what it makes it a true statement. So that's why I have to fill this in. I have to include the 4 in my solution because it actually makes it a true statement. All right, x is greater than or equal to negative 10. And let's see what the purple one is. So I want you to try those on your own and then come back. All right, go ahead and check your answers. You'll notice that I didn't add a 0 on my graphs this time. You can if you wish. It just seems to take a little extra time when I have to count it out. I know that 0 is over here someplace. I don't really need to add it on my graph. Same instance here. I know that 0 is over here someplace. It doesn't really matter as long as I'm shading in the right direction. All right, so now we're going to have solving with graphing. So same thing before, but instead of an equal sign, now I've got this inequality symbol here, but I'm going to treat it just like an equal sign. So I'm going to start out by adding 3 to both sides. That's going to give me 4x equals 6, greater than or equal to 16. And same thing as before, I'm going to divide both sides by 4, and that will give me x is greater than or equal to 4. Find a spot on your number line and call it 4. That is going to be a closed circle because of the equal sign, and then I'm shading the direction of the arrow, which is to the right. Okay, let's try another one of those. Whoa, let's see. I'm going to first draw my line down my inequality sign and treat it like it's an equal sign. So first thing I'm going to do is I'm going to subtract 1 from both sides. That's going to give me 5x less than negative 20. Again, watch your positives and negatives. Negative 19, take away 1 is negative 20. If I divide both sides by 5, that is going to give me x is less than, what's going on with my board right now? X is less than negative 4. So find a spot, call it negative 4. That will have an open circle because there's no equal sign. And then I'm going to shade to the left direction of the arrow. All right, so I want you to pause the video and write these two in your notes and try them on your own. Be careful with them, because if we have to, oh, we better not do those. We better do these together, because there's something weird going on when I divide both sides of an inequality by a negative number, and I'll show you why. I'll show you what happens. So let's say I have negative 3 is less than positive 1. So if you think about a number line, negative 3 is over here, here's 0, here's positive 1. Negative 3 is less than negative 1. Well, what happens when I multiply, or let's say divide, it doesn't really matter, both sides by negative 1? Because if I do something to one side, I have to do it to the other. Now all of a sudden I've got positive 3 is less than negative 1. Positive 3, sorry, there should be a negative over here. So positive 3, here's 0. Here's positive 3, here's negative 1 if this is 0. Positive 3 is not less than negative 1. Positive 3 is a bigger number than negative 1, so that's no longer true. So anytime I multiply or divide by a negative number, which is what I did here, hold on, bear with me. I'm divided by a negative number. So anytime I do that, I'm going to have to switch my sign. So instead of it going this way, I have to switch it and make it go the other direction. All right, so that being said, let's try these couple of problems here. So first thing I'm going to do is add 7. That's going to give me negative 2x greater than or equal to negative 6. Now I'm going to divide both sides by negative 2. Oops, I don't want that color, you can't see it very well. Divide both sides by negative 2. And that is going to, now because I divided by a negative number, I'm going to have to flip my sign and make it go the other direction. So now, notice it was greater than or equal to, now it's less than or equal to, okay? So pick a spot and call it 3. So I'm going to pick here and call that 3. And then I have to shade to the left now because it's less than or equal to, and also I have a closed circle. All right, one more. Let's try one more like that. So I'm going to first add 1 to both sides. That will give me negative 9x greater than or equal to 81. Then, of course, I have to divide both sides by negative 9. So when I divide both sides by negative 9, I have to flip my sign backwards. And that is going to be 81 divided by negative 9 is negative 9. All right, I'm going to pick this spot right here and call it negative 9. And it has a closed circle because of the equal sign. And I shade to the left. All right, combining like terms with inequalities. Same thing. So we're going to combine these two together. That's going to give me negative 3x minus 5 less than 10. Add 5 to both sides. And that will give you negative 3x. These cancel. Less than 15. Then when I divide both sides by negative 3, that is going to give me x is less than, oops, I almost did it myself. I have to flip my sign, don't I? Because I divided by a negative number, I have to split my sign over. So x is not less than 3, it's going to have to be, I'm sorry, greater than, what the heck? X is going to be greater than negative 5. So on my number line, which I don't have here, I'm just going to pick a spot and call it negative 5. And I'm going to have an open circle at negative 5 and shading to the right. Okay, let's see what we got under the big purple surprise package here. All right, go ahead and try that on your own, combining your x's and then combining your numbers, and then see where that takes you. Don't forget, if you divide by a negative, you flip it. If you divide by a positive, you do not flip it, you leave it alone. The only time you flip it is when you divide by a negative. All right, go ahead and take a minute and check your work. Make sure you combined everything correctly and that you solved and got the right answer and graphed properly. All right, guess what? We got some distribution now. So we got one more thing to add to our plate. No big deal. Okay, let's just keep going. You guys know how to do this stuff by now. So find your inequality sign, draw a line down it. Okay, so I'm going to first see some parentheses there. So number 6 is waiting to see what 8 does to the rest of that mess. So 8 times x, that's positive 8 times positive x, which gives me positive 8x. Positive 8 times negative 1 is going to give me negative 8. Less than or equal to, and I can't do anything with either of those because one has an x and one doesn't, so I'm going to leave those alone. Okay, on my left side, some like terms I can put together. I can put together that 6 minus 8, which is going to give me negative 2, plus 8x. These guys are still not doing anything. They're not going anywhere until I can get the other side cleaned up. Okay, now I can start moving stuff. Because I have two things over here on the right, on the left. One has an x and one doesn't. Same thing over here. One has an x and one doesn't. So now I'm going to start moving stuff back and forth across the line. All right, my first thing I'm going to do is I'm going to add 2 to both sides. That's going to make those cancel. That will give me 8x less than or equal to negative 18 plus 5x. Then I'm going to subtract 5x from both sides, which will give me 3x on this side less than or equal to negative 18 because these cancel. And then I'm going to divide by a positive 3. All right, so this is an important note to make for yourself. I am dividing by a positive 3, which means my sign does not change. It doesn't matter that I end up with a negative number because these two numbers were positive. And so when I divided by my positive number, the sign stays the same. All right, and then you could go ahead and graph. I'm going to pick a spot on my number line and call it negative 6. And I'm going to have a closed circle at negative 6, and I'm going to be shading to the left. All right, let's see if you can handle this next one on your own. Pause the video and give it a shot. All right, so you should have ended up with x is greater than or equal to negative 7. Because down here at the bottom you had a negative number, you were dividing by negative, so hopefully you remember to flip your sign. All right, one more example. Go ahead and pause it and try it on your own. All right, so you should have gotten x is less than or equal to negative 7. Again, because I did not divide by a negative, I do not need to flip my sign. So I'm going to come over here and put a closed circle at negative 7 because of the equal sign, and I'm shading to the left. All right, that's it for today's lesson. Thanks for watching. See you tomorrow.